Okay, hello everyone. Let's pick it up from last time. We were in the sleep section. Now, before you start coding, read chapter 1 of the Xv6 book. Okay, so we were left where we were reading a book, this book, chapter 1. Let's see if we can keep reading. Yes, yes. Okay. I don't know if this is the book that they're talking about or this is the book that they're talking about. Whatever it is, let's read it. Now it should be clear why it is helpful that fork and exact are separate calls. Between the two, the shell has a chance to redirect the child's I/O without disturbing the I/O setup of the main shell. One could instead imagine a hypothetical combined fork exact system call, but the options for doing I/O redirection with such a call seem awkward. The shell could modify its own I/O setup before calling fork exec, or fork exec could take instructions for I/O redirection as arguments, or even a program like cat could be taught to do its own I/O redirection. Although fork copies the file descriptor table, each underlying file offset is shared between parent and child. Consider this example. Fork 0, write hello, else write 0, write 1, world, and 6. At the end of this fragment, the file attached to the file descriptor 1 will contain the data hello world. The write in the parent picks up where the child's write left off. This behavior helps produce sequential output from sequences of shell commands like echo hello echo world output text. The dub system call duplicates an existing file descriptor, returning a new one that refers to the same underlying I/O object. Both file descriptors share an offset, just as the file descriptors duplicated by fork do. This is another way to write hello world into a file. Two file descriptors share an offset if they were derived from the same original file descriptor by a sequence of fork and duplicate calls. Otherwise, file descriptors do not share offsets, even if they resulted from open calls for the same file. Dub allows shells to implement commands like this: ls existing file non-existing file into temp1 2 slash n1 tells the shell to give the command the file descriptor 2 that is a duplicate of descriptor 1. Both the name of the existing file and the error message for the non-existing file will show up in the file temp1. The Xv6 shell doesn't support I/O redirection for the error file descriptor, but now you know how to implement it. File descriptors are powerful abstraction because they hide the details of what they're connected to. Process writing to file descriptor 1 may be writing to a file, to a device like the console, or to a pipe. Pipes. A pipe is a small kernel buffer exposed to processes as a pair of file descriptors, one for reading and one for writing. Writing data to one end of the pipe makes the data available for reading from the other end of the pipe. Pipes provide a way for processes to communicate. The following example code runs the program WC with standard input connected to the read end of output end of a pipe. P2, argv2, WC, okay. The program calls pipe, which creates a new pipe and records and read and write file descriptors in the array P. After fork, both parent and child have file descriptors referring to the pipe. The child calls close and dub to make the file descriptor 0 refer to the read end of the pipe, closes the file descriptors in P, and calls exec to run WC. When WC reads from its standard input, it reads from the pipe. The parent closes the read side of the pipe, writes to the pipe, and then closes the write side. Okay, these are very interesting. Is this something I can run on my own? Let's see. Let's see. Okay. Xv6 practice. Let's see. Pipe C. Into P2. Car arc P2. Arc P0. One 0 pipe dot P if fork is equal to 0. Close 0. Oh, I want to reformat all of this two space indented bullshit code. That's not called a bullshit code. It's not respectful. Okay, close. Exact. Am I missing something? Or am I? Is this the stupid mistake where I didn't put them in the main? Um, okay. Man pipe. Oh, okay. Okay. Library function. Execute a file. Oh, wait a second. The exact family of functions places the current process image. What? Does the exact not exist? Does the exact not exist? because there's no function literally named exec. Oh. Let's see Reddit post. Based on your probably want to use exec VP declared in. There's no such thing as a regular. There's an exec man page though, which mentions all of the variants. It's in the forking exec and so on. They mean one of those functions. Oh, okay. Then why did they write it here? Okay. Okay. Got it. Okay. So let's do this again, where I shouldn't be using exec function here, but the variants. Okay. 1 to 12. Hello world can be installed. Oh. Hello up. Go. Oh, okay. So there's something I did, whether it was correct or not, I don't know, but it worked. Okay, let's go back to the book, the booklet. No, this is not the book I was reading. Okay, let's expand it a bit. Shall implement pipelines such as grep fork, shell.c, wc. Oh, I even forgot how to do this. What does wc do? Word count? Oh, okay. So it's such a pipelining. Fork. I don't know if this is the right way I'm understanding things. I think I don't. Pipes may seem no more powerful than temporary files. The pipeline could be implemented without pipes as so fork it, close it, duplicate it. Okay, let's go back to where the hello world was, right? And implement this first, because I don't think I understand what's going on. Obviously, they're implementing whatever the system call that they defined initially, like this, but create a new process using the fork system call. Okay, so those are the system calls are that are already existing in the in the Xv6. What we're trying to do is make a subsequent command line, like a system calls that we can use to navigate through this Xv6 system. Or are we defining the fork ourselves? Don't know what's going on, but let's see. Let's do one by one. Load.c, int main, um, 0, printf parent child equal. Hmm. Exit into the standard library. Okay, and then there's one more. Expect a matching int argument. PID is an int, but oh, what the hell was I doing? Okay, what else was the error? Um, exit standard lib. Okay. Huh? No. Wait. Sys wait. Okay. Okay. So it looks like exec is something that exists in Xv6 only, right? Otherwise, it doesn't make sense. The code is repeatedly emerging in the Linux code. It can't be. Okay. Okay. I have file descriptor, pipelines, piping. So in the command line, you can use piping in terms of like word count. So grab hello.c. You can do piping with this one. Line count. Why is it taking so long? Did I mess something up? Um, cat hello.c. Okay, how to use WC? Okay, so that's how you use it. Okay, let's go. I don't have much time, sir. The program calls pipe, which creates a new pipe and records the read and write file descriptors in the array P. After fork, both parent and child have file descriptors referring to the pipe. The child calls close end up to make file descriptor 0, refer to the read end of the pipe, closes the file descriptors in P, and calls exec to run WC. When WC reads from its standard input, it reads from the pipe. The parent closes the read side of the pipe, writes to the pipe, and then closes the write side. Okay. So is there something take over here? GCC pipe.c a out. No. Let's do this instead. PSAUX pipe.out didn't do anything. All it did is just print 12. Why did it print 12? Is it 1 to 12? What the hell is this? What does exec do in Xv6? How exec works? Split the flow into two phases. read args, load program from disk to memory, allocate stacks, prepare the new images, read user arguments, argv, argv1, 2, 3, okay, is at 64 bits, okay, fetch address and string, int fetch address, load program and allocate, load program into memory, allocate 2 pages, one for user stack, one for guard page. Push argument strings to stack. How does stack look after pushing arguments? Code exec, core exec code for reference. Oh my god. Okay. So, pretty complicated. And I'm not going to give up. Let's see. The Xv6 shell implements pipelines such as grepfork shc in a manner similar to the code above. Okay. Hello world, wc, echo hello world, temp xyz, wc temp xyz. Pipes have at least 3 advantages over temporary files in this situation. First, pipes automatically clean themselves up with the file redirection. A shell would have to be careful to remove temp xyz when done. Second, pipes can pass arbitrarily long streams of data, while file redirection requires enough free space on disk to store all the data. Third, pipes allow for parallel execution of pipeline stages, while the file approach requires the first program to finish before the second starts. The Xv6 file system provides data files which contain uninterpreted byte arrays, directories which contain named references to data files and other directories. The directories form a tree, starting at a special directory called the root. The path ABC refers to the file or directory named C inside the directory named B, inside the directory named A, in the directory slash. Paths that don't begin with slash are evaluated relative to the calling process's current directory, which can be changed with the chdr system call. Both these code fragments open the same file, assuming all the directories involved exist. The first fragment changes the process's current directory to AB. The second neither refers to nor changes the process's current directory. There are system calls to create new files and directories. mkdir creates a new directory, open with the O-create flag creates a new data file, and mknod creates a new device file. This example illustrates all three. Make dir ft open dir file will create all read only. Makenod creates a special file that refers to a device. Associated with the device file are the major and minor device numbers, which uniquely identify a kernel device. When a process later opens a device file, the kernel diverts read and write system calls to the kernel device implementation instead of passing them to the file system. A file's name is distinct from the file itself. The same underlying file, called an inode, can have multiple names called links. Each link consists of an entry in a directory. The entry contains a file name and a reference to an inode. An inode holds metadata about a file, including its type, its length, location of the file's content on disk, and the number of links to the file. The fstat system call retrieves the information from the inode that a file descriptor refers to. It fills in a struct stat, defined in stat-h as tdar, tfile, tdevice, dev, inode, type, and link size. The link system call creates another file system name referring to the same inode as an existing file. This fragment creates a new file named both A and B. Reading from or writing to A is the same as reading from or writing to B. Each inode is identified by a unique inode number. After the code sequence above, it is possible to determine that A and B refer to the same underlying contents by inspecting the result of fstat. Both will return the same inode number, and the nlink count will be set to 2. The unlinked system call removes the name from the file system. The file's inode and the disk space holding its content are only freed when the file's link count is 0 and no file descriptors refer to it. Thus, adding unlink A to the last code sequence leaves the inode and file disk content accessible as B. Furthermore, fd equal open O create or no read write unlinked temp xyz is an idiomatic way to create a temporary inode with no name that will be cleaned up when the process closes fd or exits. Unix provides the file utilities callable from the shell as user level programs, for example mkdir, ln, and rm. This design allows anyone to extend the command line interface by adding new user level programs. In hindsight, this plan seems obvious, but other systems designed at the time of Unix often built such commands into the shell. Oh no! I didn't intend to click that. Oh no! Where was I? Um, cd must change the current working directory of the shell itself. If cd were run as a regular command, then the shell would fork a child process. The child process would run cd, and cd would change the child's working directory. The parent working directory would not change. Unix's combination of standard file descriptors, pipes, and convenient shell syntax for operations. Uh, okay. How long did I record it? Oh,